This video is for 14.2. So today we are going to be working more with those line plots and those dot plots. So those words can be interchangeable. So it's got a line and it's got dots or X's above it. So our goal today is that we can construct and analyze. That just means interpret all of the information. We can understand what the numbers on the bottom mean. We can understand what the dots are representing and answer questions using that information. So if you can do that with the whole numbers, then that is our goal today. We're going to do a couple practice problems that you will not find in your task. So at the end of this video, we're going to do some above levels. So stay with me for those to try out some fraction problems. So if you're understanding the fraction problems, that's going to bump you up to a level 4 today. If you can make the dot plot, so construct means to build or make a dot plot, and you can understand what each of the dots are representing, then that is a 2. So you can't maybe answer all the questions, but some of the questions. And if you can just make the dot plot, but you're not sure about the questions, then that is a 1. So you can make it and answer the questions is our goal today. So before we get going, some information we need to just understand is remember those statistical questions are questions that can be answered with a variety of answers, and we can collect and then we can analyze or understand that data. So one really nice way to use the data is to make a visual display, a graph, a chart. So a dot plot is just a type of line plot that shows the frequency of each data value using a dot. You can use an X, a dot. So sometimes you might see a picture, and they call that like a pictogram, is another type of line plot. So a dot plot is just a nice visual, so we can see it, visualize it, in which each piece of data is represented by a dot above a number line. So every time they ask a person a question, their answer is represented by a dot on the number line. So every dot represents one observation or one answer. The number of times a data value occurs is called the frequency. So if you asked, like you had colors, like what's your favorite color? Blue, red, green, purple, so on, so on. And 10 people answered green, the frequency of green would have 10 dots above it. So we could easily see, 10 people like the color green best. So it's just a really nice way to quickly gather your information and understand, this one had the most, this one had the least. I can see how much they are spread out. When we have these numbers, as we'll see in a second, that are just in these tables and no real order to them, it's a lot harder to answer some of these questions that will be asked of us. So this first one here tells us that a pulse rate is the number of times a heart beats per minute. The pulse rate for a group of 12-year-olds is taken before physical education class. The results are shown in the table. Which pulse rate is the most common in the group? So here's all their pulse rates. And right now, there's no real order to it. It's just here's the first kid, second kid, third kid. And we would really have to go through and pick things out. So a better way is to go ahead and make a dot plot and organize that information. And then we can understand a lot of information about these data points. So what do you think our number line should look like? So we want to find the smallest number and the biggest number because, if I only put my number line from 70 to 75, I can see, I'm missing out on all of these numbers that are in the 50s, the 60s, the 80s. So we need to find our smallest number and the biggest one. So look through and see if you can identify those. So looking through, so here's a 58. Let's see if we have anything smaller. 55. Looks like, so 55 is our smallest number. And now we want to go through and find the biggest number. So take a look and see if you can find the largest number or the highest pulse rate. So I'm looking through. So I see an 85. So looking for numbers in the 80s. That's still smaller. And our highest number is 85. So our number line needs to go from 55 to 85. Now, maybe we don't need to necessarily, I think we might need to count by every number because, right, I can see a 56 on here. Somewhere I saw it on there, 57 and 58. So if I skipped and was only counting by fives and I just said the next number is 60, it would have a hard time knowing if I put a 56 on here and put my dot above 56, which one that was really on. So we do want to count by ones on this one because we do have numbers that are changing in the ones place. If we only had numbers that were like 1,000, 2,000, 3,000, then we could count by thousands. But since we have numbers in the ones places that are differing, we need to make sure we're counting by ones. If you're just counting by tens, 10, 20, 30, 40, 50, then we could just count by tens. So you've got to be mindful of what your scale is. So we are going to create our dot plot here. So go ahead and in Ed, you can take a second and you should open it up. There's a place for you to draw and you can, so I say 65 and I put a dot above 65. So I have 58, I put a dot above 58. So I like to kind of mark them off. Yep, I've done these. So I do 67, just kind of keeps my place. So go through and make your dot plot. So pause the video, make your dot plot, and then come back and let's see if we have the same dot plot. So here is my dot plot. So I can see there are some pulses like 61, 62, 64 that nobody had that pulse rate, and that is okay. So, right, I can just identify, right, nobody has these pulse rates because there's nothing above it. So this first question wants to know what is the most common pulse rate? Well, looking at our dot plot, we just look for the one that goes up the highest, that has the highest frequency. And since it's very visual, we can just see which one goes the highest. Well, that's right here, 75. In our chart, I could go through, right? There's one of these, and I can go through and looking. Oh, okay, let's see. Oh, here was one. I missed it, right? So there was two 65s, and then I could look for 58. Oh, okay, there's no more 58s, right? That's going to take a long time to see which one happened the most and make sure you're not missing information. By putting it in this dot plot, boom, I can see 75 was the most common pulse rate. So go ahead and complete task 1 and then come back when you are ready to do task 2. Hey, task 2 has already created this dot plot for us. So we're going to be answering these questions about it. So a company's employees are rated for their customer service on a scale of 1 to 10, with 1 being very unhappy and 10 being very happy with their service. The customer service ratings for one day are shown in the dot plot. Use the dot plot to describe the data. So we can see, right, one person was really unhappy. They had 4 people that were really happy. So these numbers on the bottom are the ratings. And what would each dot represent in this case is representing a customer that they talked to that gave a rating. So this is someone they helped. This was their rating that they gave. This is someone they helped. This is their rating. This is someone. So each of these dots are a different person. So our first question asks, what is the most common rating? So we're looking for the rating that has, so not necessarily, so we're not looking for the highest rating, we're looking for the rating that has the most. Okay, so look through. So which of these has the most dots? So I can see this 7 goes up the highest. It has the highest frequency. So 7 was the most common. Now we're looking for the least common rating. So we're looking at our ratings and looking for which one has the lowest frequency. So which of the dots are lowest on the scale. And good for them. They only had one person that was unhappy with their service. Well, I mean, they had a few people that weren't super happy, but only one person was very, very unhappy. Now it wants to know how many observations are shown on the data plot. So remember, our observations are each person that they asked that question to. So to find how many observations there are, we just go ahead and count all of the dots to get that answer there. Okay, so now we're going to try a little bit harder of a question here, and this will be good review for us. So if a rating of 6 or higher is considered acceptable, so they're like, oh, we'll take that. What percentage of the ratings are unacceptable? So they want to know how many are not good enough. So 6 or higher, so they can have 6 or more and be considered acceptable. So all of these are acceptable. So that means all of these ones over here are unacceptable. And we want to know the percentage of them. So our percentage, we put our part over the total. And remember, percentages are always out of 100. So we are looking for this percent out of 100. So now we need to get our pieces and our total from our chart here. So we're looking for the unacceptable ones. So we want to count how many are unacceptable. So go ahead and do that. So I see 4 plus 1 is 5, 6, 7, 8, 9, 10, 11, 12. So 12 of these are unacceptable. And then we need out of the T for total, right? They surveyed 100% of their customers. Here's their customers for the day. We need to know how many that was, which if you come back here, you've already figured out how many total observations there are. So just to be sure, so we had 12 on this side. So 12 here. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 on this side. So I need my total of those together is 40. So now we are looking for this percent here. So we need to get P all by itself. So the opposite of divide by 100 is to multiply by 100 on both sides. So this cancels out because it's a fraction. So I am multiplying by 100. So 12 times 100 is 12 with 2 zeros. And then I'm dividing that by 40. So 1,200 divided by 40 will give us our percent of the unacceptable service ratings. Okay, so we were looking for unacceptable. So how many were unacceptable out of the total? Percentages are always out of 100. Okay, so now our next question says if a rating of 8 or higher is considered excellent, what percentage of the ratings are excellent? So this time it wants to know how many were excellent. So I'm just going to erase some of that work there. So again, remember we're looking for the part over the total. And we know our total number of customers was same. No, the dots have not changed, is 40. We're looking for the percent. What percent? Percents are always out of 100. So now we're looking for 8 or higher. So we need to see the piece that is 8 or higher. Let's go ahead and count those up. So here's 4, 8, 9, 10, 11, 12, 13, 14, 15. So this time we have 15. So we need to get, again, P all by itself. So the opposite of divide by 100 is to times by 100. So these cancel out. So 15 times 100, 1,500. And then we're going to divide by 40. So 1,500 divided by 40 will give us the percent of people that considered their customer service excellent. So go ahead and solve that. So what do you think would happen to the information if 5 more customers, 1, 2, trying to line these up and I'm not doing a very good job. I'm going to make my pen a tiny bit bigger here. So we've got this one here. So we're adding on, I'm trying to line them up. 1, 2, 3, 4, 5. Okay, kind of did it. So what do you think would happen if we added on 5 more customers with a rating of 10? So is our data going to stay the same? So, well, we just added on more people. And so how would the previous percentages be affected? So we compared the ones that were 5 and below. Well, now there's even less of those compared to these ones. So I think the percentage of what was the word they used? Unacceptable ratings would go down because now there's more of these. And the ones that were excellent are going to go up because now there's more of those. So the unhappy people now became lower and the happy people became higher because we just added a lot of very happy people. So even just adding a few new data points can change your information. So go ahead and complete task 2 with that information that we've talked about, and then come back when you are ready to do task 3. So task 3 is about water and how much we should drink. So the recommended amount of water that each person should drink per day is shown. So we should drink 8 glasses of water every day. Students were asked to track how much water they actually drank in a day. The number of glasses of water they drank on a specific day is shown in this list, right? We can see these numbers are not in order. So they're kind of hard to look at and see, like, how many of these do we have? How many did this? Who had more? Who had less? It's way quicker just to put it on a dot plot. So we can see our numbers go anywhere from 0 up to, I see a 9. Looks like it's the highest. So we have a number line that goes from 0 to 9. So go ahead and take a minute and complete your dot plot. So just go through a number at a time. So put your 5 on your dot plot, put your 7 on your dot plot. And now remember, we want to keep these in line. And then when we make a second level, we want to try and keep those in the same line as well. It's okay if it's not perfect, but right, if I put my 7, whoops, that's not what I wanted to do. That's not my eraser. If I put my 7 to start like up here and my next one here, right? It's going to look like the 7s are higher, even though they both had 1, 2, 1, 2. So as you're going through, do your best to kind of keep those level there. So go through each dot and put them on your dot plot and come back and see what mine looks like. So here is my dot plot. So we're going to answer a few questions here. What is the most common number of glasses of water students drink? So we're looking for the highest, most frequent number. So looks like our tallest point of our plot is here. So the most common glasses of water is 5. How many students drank at least the recommended amount of water per day? So if we remember, it's recommended to drink 8 glasses. So they said at least that. So who drank 8 or more? So we can, let me move my head here. It's in the way. So how many people drank 8 or more? So we just count each of the dots because each dot represents one student. So these numbers down here represent how many glasses they drank. This is our measurement. The dot represents a person or a thing that did that. So now it wants to know how many observations are shown in the dot plot. So observations all together. So we just count each of the dots. So go ahead and do that. So I got 25. Hopefully that is what you got. So here's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay. It's important that we get those numbers correct, right? If I accidentally said there was 24 or 26, it could throw off future questions. Like this next one asks what percentage of students did not drink the recommended glasses of water per day? Well, we've got to have our total as part of that. And if I have my total wrong, it's going to get my percentage wrong. Then I'm missing 2 questions. So part over total. So we know there are 25 total students that participated. And it wants to know how many did not drink the recommended amount of water. So if you remember, these are the recommended ones. So everything else did not hit the recommended amount of water. So I can see there's only 4 that did. So I can just take that away. Instead of counting all of these, I can just think 25, take away the 4 that did not hit the goal, or that did hit the goal, because I'm looking for how many did not, is 21. Now we're looking for the percent out of 100. We want to get P for percent all by itself. So we're going to divide by 100. And so, sorry, not divide. That's not me. I was like, this is divide. We want to do the opposite. We want to do the opposite, which is to times by 100. It's going to have us really confused there. So that cancels out because this is a fraction. So this is like 1 over 100. And this is 100 over 1. So this is a whole number, right? This is the denominator. So it turns into 100 over 100, which equals 1. 100 divided by 100 is 1. So that's why that works out. So that's canceled on that side. So we're timesing by 100 here, which turns into 1 with 2 zeros. So 21 with 2 zeros. And then we're dividing that by 25 will give us our percent of students that did not drink that water. So I know it's going to be a pretty high percent because there's only 4 people that did drink enough water and the rest of them did not. So right, that's definitely more than half. And I'm even thinking it's going to be much closer to 100 than anything else. So, it's not going to be 100, right? 100% of the people are not included in this part, but it's going to be a pretty high percent. Let's go ahead and complete task 3. So these things are our level 3 kind of questions. So if you can answer these questions here based on these whole numbers, that's a great way to gauge, are you a 3? If you can just count the dots and you're like, yep, I know how many dots are on the plot because that's each student, that's a 2. And if you can just make this, then that is a 1. So we're going to go on and practice some above level 4 questions. So go and do task 3 and then come back and see if you can do these other extra ones with me that I think will help get you prepared for some homework. So we've got this dot plot here, so you can see the X's, and this is our hours spent reading. So they asked each student, how many hours did you spend reading maybe this week? Okay. And so every X is a student's answer. And we're going to answer some questions with this information here. So what was the amount of time that the students that read 2.5 hours read all together? So we're looking for our time of 2.5. So we're right here. And the question doesn't want to know how much did they read. We know they read 2.5. It tells us that. It wants to know how much did each of these students read all together. So how much did this student read? 2.5. This one read 2.5, 2.5, 2.5, 2.5. So I'm hearing that I have 2.5, 1, 2, 3, 4, 5 times. So we need to make our fractions improper. So here's 4 plus 1 is 5 over 2 times 5 over 1 equals 25 over 2. And now we just need to simplify. So 2 goes into 25 12 times, which is 24, with 1/2 left over. So the total amount of hours that all of these kids right here read together was 12.5 hours. What is the difference? So this time we're going to be subtracting something. In the amount of time, all the students that read 3 hours. So all of these students and their time. So let's find that one first. So this is a nice whole number. So this one should be easy. 3, 6, 9, 12. So these students read 12 hours together. And we're going to subtract and compare that to the students that read 1 and 3/4 hours. So we need to figure this one out. So we have 1 and 3/4. And how many kids read that amount? 1, 2, 3, 4. So we're going to multiply that by 4. So we need to make this improper. So here's 4, 5, 6, 7 over 4 times 4 over 1. So I notice these cancel out. So I end up with 7 over 1, which is just 7. So to find that difference, 12 minus 7 is 5. So these 4 students spent 5 more hours than these students together. So as you're reading these questions, you got to decide, find the numbers on the bottom. What does that mean with these? What is the question asking me to do? You've got to really think about, what data should I be using here, right? It's not just 3 minus 1 and 3/4. It didn't say what's the difference in this minus this. It said all of these students' time compared to all of these students' time. How many more students read 2 or more hours than the students? So this time we're not talking about time. We're talking about how many students. So that should have an S on the end there. How many more students read 2 or more hours? So 2 or more. So we're separating our dot plot here. So here's a group. And then less than 2 hours. So 2 or more. So we'll find out how many students read 2 or more. So we're going to count our students. Here's 2, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16 students read 2 or more hours. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students read less than 2 hours. And it asked how many more. That's a good subtraction phrase. How many more is 6. There's 6 more on this section than this section. What percentage of the students did not read more than 2 hours? So what percentage of students did not read more than 2 hours? So these guys did not read more, these didn't, these didn't, these didn't. We've got to decide, should we include our 2? So it says more than 2 hours. Well, this is not more than 2 hours, it's exactly 2 hours. So I think we'll include those here. So these are the ones that did not read more than 2 hours. So that's our piece. And then we'll have to see what is our total. So, and we're looking for percent, which is out of 100. What percent out of 100? So let's see how many people did not read more than 2 hours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 students did not read more than 2 hours. Out of, so here was 12 total, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 total. So we want to get P by itself. So the opposite of divide by 100 is to multiply 100, which cancels that out. Then I do it over here. It's always good to show what we're doing and make sure we're keeping everything balanced. I know it's easy just to put your 100 over here, but show me what you're doing. So we've got 12 times 100 is 1200. And then we would divide that by 26 to get our percent of students that did not read more than 2 hours. So I can kind of see, right? 12. So 12 doubled is 24. So this is just a little bit less than half. So our number should probably be around 40 something percent, because that's a little bit less than half at 50%. Okay, so those are all the questions I wanted to go over. So again, if you feel like you can construct and answer questions with whole numbers, that's great. That will get you off to a good start in your 3 today. If you really understood those fraction questions, and you're like, yeah, I could do that on my own, that will bump you up to a 4 today for your I can. If you could make the dot plot and just count the dots on it and see how many people answered the questions, that is a 2. And if you can just make the dot plot, that is a 1. So go ahead and complete your check for understanding today and your tasks, and then let me know if you need any other help.